exotic world.
Hey everyone, welcome to the show and get ready to dive into a cosmic pool of head-scratching wonder. We're about to explore the universe's weirdest, most mind-bending paradoxes. These aren't just riddles for philosophers, these are puzzles that have stumped mathematicians, physicists, and even regular folks like you and me for centuries. So, buckle up because we're about to launch into a realm where logic gets turned inside out and the only constant is a good dose of cosmic confusion. Let's kick things off with a classic from the ancient Greeks, a real head-scratcher from Zeno of Elea. Imagine an arrow flying towards a target. Seems simple, right? But Zeno asked, how does that arrow actually get there? He proposed that to reach the target, the arrow must first travel half the distance. Then it needs to cover half of the remaining distance, and then half of that distance, and so on, infinitely. You see, no matter how small the distance gets, you can always divide it in half again. This, my friends, is the dichotomy paradox. It suggests that motion is impossible because we'd have to cross an infinite number of points in a finite amount of time. It's enough to make you want to just stay put, but don't worry, we'll keep moving. This next paradox is a real identity crisis, and it's been messing with philosophers for ages. It's called the Ship of Theseus paradox, and it raises some profound questions about identity and change. Imagine a ship, let's call it Theseus's ship. This ship has been sailing the seas for years, weathering storms and docking at various ports. Now, over time, parts of the ship need replacing. A plank here, a sail there. Perfectly normal, right? Maintenance is essential to keep the ship seaworthy. But what if, over time, every single piece of the original ship is replaced? Imagine that every plank, nail, and sail has been swapped out for new ones. Is it still the same ship? This question has puzzled thinkers for centuries. If none of the original materials remain, can we still call it Theseus's ship? Now let's take it a step further. Imagine someone collected all the old replaced parts and built a second ship identical to the original. This second ship is made entirely of the original materials. So which one is the real ship of Theseus? The one that has been continuously maintained and updated, or the one rebuilt from the original parts? Which one is the real ship of Theseus? This question forces us to think about what makes something fundamentally itself. Is it the material it's made of, or the continuity of its existence? This paradox isn't just about ships. It makes us question the nature of identity, change, and what it means for something to remain the same over time. It applies to everything, from objects to living beings. It's enough to make you wonder if you're still the same person you were yesterday. After all, our bodies are constantly changing too. Cells die and are replaced, memories fade, and new experiences shape us. So are we still the same person we were years ago, or have we become someone entirely new? Now let's grapple with a paradox that's puzzled theologians and philosophers for centuries, the omnipotence paradox. It centers around the concept of an omnipotent being, a being with unlimited power. If such a being exists, could it create a stone so heavy that even it couldn't lift it? If it could, then there's something it can't do, lift the stone, which contradicts its omnipotence. But if it can't create such a stone, does that mean its power is limited? This paradox forces us to confront the limits of logic and the potential contradictions inherent in the very concept of omnipotence. It's a brain twister that reminds us that even the most powerful concepts can be riddled with paradoxes. Hold on to your hats, folks, because we're about to dive into the world of set theory with Russell's paradox. This one's a real doozy, discovered by the mathematician and philosopher Bertrand Russell. It deals with sets, collections of objects, and a seemingly simple question, can a set contain itself? Imagine a set of all sets that don't contain themselves. Let's call it R. Now, the million-dollar question, does R contain itself? If it does, then it shouldn't, because it's defined as a set of sets that don't contain themselves. But if it doesn't contain itself, then it should, because it fits the definition of the sets it's supposed to contain. This paradox shook the foundations of mathematics and logic, revealing that even our most fundamental concepts can lead to mind-boggling contradictions. Chapter 5, The Interest Paradox of Numbers. When numbers behave badly. Numbers, those seemingly simple building blocks of mathematics, can be surprisingly weird. The interest paradox of numbers highlights just how strange they can get. Imagine you have a certain amount of money in the bank earning interest. Now here's the kicker. The paradox suggests that the amount of interest your money earns in a year is independent of the initial amount you invested. It seems counterintuitive, right? You'd think more money would equal more interest, but this paradox plays with the relationships between numbers, rates, and time in a way that defies our everyday intuition. It's a reminder that even in the seemingly ordered world of mathematics, there are still mysteries to uncover. Chapter 6. The Birthday Paradox. Coincidences aren't so coincidental. Get ready for a probability puzzle that'll make you question everything you thought you knew about coincidences. The birthday paradox is a fascinating concept that challenges our understanding of probability and randomness. The birthday paradox asks a simple question: how many people do you need in a room to have a greater than 50% chance that two of them share the same birthday? At first glance, this might seem like a straightforward question, but the answer is anything but intuitive. Intuitively, you might think you'd need hundreds of people. After all, there are 365 days in a year, so it seems logical to assume that you'd need a large number of people to find a shared birthday, but the answer is surprisingly small, just 23. This counterintuitive result is what makes the birthday paradox so intriguing and mind-boggling. That's right, in a group of 23 people, it's more likely than not that two people share a birthday. This surprising result is due to the way probabilities compound as more people are added to the group. This paradox highlights the counterintuitive nature of probability and how our intuition about chance can often be misleading. Our brains are not naturally wired to understand the complexities of probability, which is why the birthday paradox seems so surprising. So, the next time you're in a room with 23 people or more, remember the birthday paradox and impress your friends with your newfound knowledge. You can explain how this paradox works and why it defies our common sense. It's a great conversation starter and a fun way to delve into the fascinating world of probability. The birthday paradox is just one example of how probability can surprise us. There are many other paradoxes and puzzles in the world of mathematics that challenge our understanding and make us rethink what we know. Embrace these challenges and let them spark your curiosity and wonder about the world around you. So dive into the world of probability and explore the many fascinating concepts it has to offer. Whether you're a math enthusiast or just someone who enjoys a good puzzle, there's always something new to learn and discover. And who knows, you might just find yourself seeing the world in a whole new light. Chapter 7. The Twin Paradox. Time travel, relativity, and ageless astronauts. Fasten your seatbelts because we're about to blast off into the mind-bending world of Einstein's theory of special relativity with the twin paradox. This thought experiment is one of the most fascinating and perplexing concepts in modern physics. Imagine two twins. One stays on Earth, while the other embarks on a high-speed journey through space. The twin on Earth continues with their daily life, experiencing time as we all do. Meanwhile, the spacefaring twin is traveling at speeds close to the speed of light aboard a spaceship that cuts through the fabric of space-time. According to special relativity, time slows down for objects moving at such incredible speeds. So, when the spacefaring twin returns to Earth after their cosmic voyage, they'll have aged less than the twin who stayed behind. This means that while years might have passed for the Earthbound twin, only a few months or even weeks might have passed for the traveling twin. This paradox arises from the seemingly symmetrical nature of time dilation. Both twins see the other as moving, and thus each would expect the other to age more slowly. From each twin's perspective, it's the other twin who's moving and therefore aging slower. This creates a puzzling scenario where both twins believe they should be younger than the other. The resolution lies in the fact that the traveling twin undergoes acceleration and deceleration, breaking the symmetry and leading to the difference in aging. The journey involves changes in velocity, which means the traveling twin experiences forces that the earthbound twin does not. The twin paradox is a classic example of how special relativity challenges our everyday understanding of time and space, showing that time is not absolute but is relative to the observer's frame of reference. This thought experiment not only highlights the strange and non-intuitive nature of time dilation, but also opens up a world of possibilities for understanding the universe. Imagine the implications for future space travel. If humans could travel at speeds close to the speed of light, We could potentially explore distant galaxies within a single human lifetime, while centuries might pass on Earth. This could revolutionize our approach to space exploration and our understanding of the cosmos. However, the technological and energy requirements to achieve such speeds are currently beyond our reach, but the twin paradox remains a tantalizing glimpse into what might be possible as our technology advances. Scientists continue to study and explore these concepts, pushing the boundaries of our knowledge and challenging our perceptions of reality. The twin paradox is more than just a thought experiment. It's a gateway to understanding the fundamental nature of our universe. So as we ponder the mysteries of time travel, relativity, and ageless astronauts, we are reminded of the incredible journey of discovery that lies ahead. The universe is vast and full of wonders, and the twin paradox is just one of the many keys to unlocking its secrets. Outro, keep those brain cells buzzing. So there you have it, folks. 7 mind-bending paradoxes that have puzzled thinkers for centuries. These paradoxes remind us that the universe is full of mysteries, and sometimes the more we learn, the more we realize we don't know. But that's the beauty of it all. These paradoxes challenge us to question our assumptions, think critically, and embrace the unknown. Don't forget to like, share, and subscribe for more mind-expanding adventures.